Hello, today is December 5th, and I'm Bhavani Thuraisingam from the University of Texas at Dallas. And the purpose of this video presentation is to give you an overview of the class that I taught during fall 2020, and that was on big data, security, and privacy. We had a grant, or we still have a grant from the National Science Foundation, which we got around three years ago. And as part of the grant, it was an education grant. And as part of the grant was to develop curriculum and materials for the big data, security, and privacy course. And so my talk today is only going to cover the lecture portion of it. In addition to the lectures, student also had a fairly extensive programming project that was based on the lectures, any one of the topics that we covered during the lecture. So it was 36 lectures. And so some lectures were covered as part of one lecture period. So because my class was conducted every Friday from 4 to 6:45 p.m. And so sometimes I would squeeze in, say, 2 or 3 lectures in one class, and sometimes I would cover one lecture for the entire class period. So anyway, what I'm going to do is to just discuss the overview. So we use Microsoft Teams for recording the lectures together with closed caption, but I'm not going to present the details of the lectures, meaning not the lecture materials, but just the introduction part. And so what I'm planning to do is to get detailed feedback from students, and I'm planning to offer this course again in the fall of 2021. And hopefully fall of 2021, we can offer this course in person. Unfortunately, due to COVID-19, this class was conducted online. And as I said, we used Microsoft Teams as well as e-learning, Blackboard e-learning for storing the lectures. Okay, so I'm going to share my screen. Oh, one more thing I wanted to say. I also teach various other courses. So I started with data and application security data and application security. That's my area. So I taught it for about 10 years. Then off and on also I taught digital forensics, although that was not my area. There was really no one really to teach that course. So I taught that course. Then once I think I taught biometrics. So I'm going to get back to biometrics again sometime in the near future, because there's so many exciting topics now in biometrics, especially with machine learning. And then I also taught a course on semantic web services and semantic web that then evolved into web services and security. So secure web services and cloud computing. And now it's developing and securing the cloud. And then I also taught a course in analyzing and securing social media. So that was in 2013. And I still do teach the class once a year or maybe once every other year. So essentially, I started teaching data and application security in the spring of 2005. And then my last time I taught was in fall of 2014. But I'm going to teach again in spring of 2021 because the colleague who teaches the course is taking a sabbatical. So I'm teaching that course. So then biometrics was, I believe, fall of 2005. And then I started teaching the semantic web course, securing semantic web, I think in 2006 or 2007 fall. And then that evolved into developing and securing the web services and securing the cloud. And that was, I believe, in around spring of 2012. So I've been teaching it every year or every other year. And then spring of 2013, I started teaching analyzing and securing analyzing and securing social media. And then that was taught sort of every fall, but now I I'm teaching it in the summer because now I teach the big data security and privacy for the fall. And then fall 2020 is the first time I'm teaching big data security and privacy, but I do use some of the material that I've taught before in cloud computing, as well as in secure social media, as it relates to big data. Okay, so I'm going to share my screen. Okay. So it's the description of the lectures. Big Data, Security and Privacy. It's a graduate course at the master's level. And I'm just going to describe the, describe the lectures. So what I covered, excuse me. So the course was covered into 8 modules. Module 1 provided the background information needed for the course. So both in cybersecurity and big data. I'm going to go into more details. Module 2 provided an overview of big data security and privacy. That also included overview of big data for security, securing big data, adversarial data science, machine learning. Module 3 discussed the infrastructure part, right? So when you talk about big data security and privacy, I discussed secure infrastructure, secure data management, and secure applications, and then several special topics. So module 3 was a secure infrastructure, which was essentially based on cloud computing, and the Hadoop MapReduce platform is what I used. It's because cloud computing is a key technology for managing big data. It provides scalability for storing and querying big data. And then we discussed access control models. In addition, we also discussed security for big data platforms and infrastructure such as Hadoop and MapReduce. Module 4 provided the core functions. So query processing, not transactions, query processing, storage management, access control. Access control models, secure query processing, and secure query management. In addition, I also discussed example secure big data system and big data governance. And then module 5 discussed an application. So the application I discussed was social media. And then we talked about social media security and privacy, because social media is a big data system. Remember, Hive database was developed by Facebook, and then it was made open source. So we discussed social media security and privacy, social media analytics, some of the privacy implications, various attacks to social media, and also how do we represent social media. So we use semantic web to represent social media in order to discuss the properties. Module 6 was some of the emerging topics, integration of cybersecurity and data science. In fact, some of the topics I discussed in module 2 were elaborated, provided more details, such as data science, machine learning for cybersecurity, intrusion detection, insider threat detection, malware analysis, and then also adversarial machine learning. So I did briefly touch upon adversarial machine learning in module 2, but in module 6, we went into details such as adversarial support vector machine. What happens if the machine learning techniques are attacked? Then I also talked about cloud for malware analysis, because cloud can actually speed up the process, right? So you take a machine learning algorithm, data science application for cybersecurity, and then re-implement that whole thing in the cloud so that you for cybersecurity applications such as malware analysis, and that would improve your performance. Module 7 was sort of mixture of all the emerging topics. So securing IoT with respect to big data and security, blockchain for big data and cybersecurity, knowledge graphs and security. So knowledge graph is sort of a more extended technology from semantic web, and cutting edge topics such as quantum information processing. This is going to be the big thing for the future. So we are introducing quantum computing, or I introduced quantum computing as it would provide us with solutions to carrying out massive computations, especially on encrypted data, sort of massive amounts of data, but there is also a big concern. So I'll talk about that. Okay. And then module 8, we talked about, sorry, I haven't underlined module 8. Anyway, we didn't cover module 8 because we didn't have time. It was only one semester and there was so much material to cover, 36 lectures in all. And so I may offer a part 2, like an advanced big data security and privacy for PhD students possibly. And what we will do, what I'm hoping to do, it's not being fixed yet, set yet. If at all it happens, it's going to be in the spring of 2022. Sample security papers from big data conferences. Because of time constraints, we will only list the, I'll just list the papers. Okay, so I listed some papers for the students or I will be listing for them to read in the future, but we're not going to cover that. Such paper reading could perhaps be included for a follow-on course, Advanced Big Data Security and Privacy. And then I do offer complementary courses, data and application security, developing and securing the cloud, analyzing and securing social media. So my colleague now offers data and application security, and then another colleague offers big data analytics. All of that will enhance the current course, big data security and privacy. Okay, so lectures 1 to 36, first introduction, right? Introduction to the course will have, I talk about an overview. It is divided into 8 modules covering various aspects of big data security and privacy. The introduction, I also talk about what is expected from the students, the exam 1 and then exam 2, and their programming project. They also have to write term papers. The programming project is fairly extensive on any of the topics that we have discussed in class. And then background for big data security and privacy. So there are 7 lectures. So what I do, I don't cover all of the 7 lectures at the same time because students would get impatient. They want to get to the sort of the meat of it, right? So the big data security and privacy topics. So I start at least the first day, I provide just the background, like cybersecurity, right? So I take it from the cybersecurity essentials, some of the modules, because I also did my CISSP Computer Information System Security Professional in 2010. I passed and I was a CISSP member until 2016. I have, let it lapse. So I hope I can get it reinstated. It's sort of 4 years. I'm not so sure now. Anyway, that was very useful. So I still teach that. But all that covered in sort of one lecture period, right? Half a lecture period. And then I also talk a little bit about access control in databases. That's the sort of the first day. And then I teach the other material, right? Access control is, in databases, what sort of access control, RBAC and things like attribute-based access control. And then data mining for malware detection. Also give an overview of semantic web because we use semantic web to represent social media, and then give an introduction to data privacy, then talk about big data management, which I don't talk about security there. So I talk about big data management, what are the technologies, Hadoop, MapReduce, Storm, Spark, and various databases like Hbase and MongoDB and Cassandra. And so very interesting. Lecture 6 and lecture 7 is on malware. So what types of malware and how can malware change its patterns? So just give an overview of malware. It's based on a talk I gave to the general public, like in public libraries and various associations, non-computer scientists. So that's what I cover in lecture 7. But remember, lectures 1 to 7 are not in order. 1 and 2, I start with 1 and 2, and then in between throughout, just before I need a particular lecture. So before social media, I will talk about semantic web, right? And before some talks on data mining for malware detection, I'll provide an overview of malware. So that's the first 7 lectures, and these lectures are not included in the exam. But exam lectures start with lecture number 8, which is module 2 is going to provide you with an overview. So first I start with big data security and privacy. So what are some of the unique aspects of security for big data? And what about some of the unique privacy aspects that you don't have, say, in just data security and privacy. More or less, they are the same, but of course, the techniques have to scale. And then I talk about secure data science, very high level. How do you apply data science for cybersecurity? And then what happens if the cybersecurity techniques are attacked? And then I give an example application, like, for instance, Internet of Transportation, like all these cars talking to each other. So it's a fairly high level. Then lecture 10 is something very near and dear to me because I did a lot of work in the late 80s, throughout the 90s and early 2000s, and something called inference control. You can put collections of data together and infer something that is highly private or highly sensitive. Put unclassified pieces of data together and infer something that is top secret. So I talk about different types of inference controllers I have designed and developed together with my colleagues and students. First, it was something that we developed really from scratch, because back in the early 1990s, we didn't have all these technologies, right? So then when I joined the university, so late 2000s, 2008, 9, 10, we re-implemented all of those systems we implemented in the 1990s. And that was using semantic web technology and reasoning engines. So that was quite interesting. And then lecture 11 was on the various big data tools, like high-level overview of Hadoop, MapReduce, Hbase, Cassandra, Spark, Storm, all of the infrastructure tools and all of the data management tools. Okay, so these were some of the topics for module 2. Now that's sort of a high-level overview of big data security and privacy. Then we delve into the details. So, okay, right, infrastructures, data managers, and then applications with respect to security and privacy. So for the infrastructures, I said, okay, we need to focus on cloud. I mean, I could have discussed other infrastructures. For one thing, I'm very familiar with secure cloud as well as Hadoop and MapReduce. So I start with introduction to SOA, service-oriented architectures and secure cloud computing. Then I talk about something that's very interesting to me, how you can use a cloud for sharing massive amounts of information in the cloud, right? Putting all the policies and data in the cloud, and how do you share the data among organizations. So this was important for us because we did a project for the Air Force where University of Texas at Dallas, King's College London, and University of Insubria, Italy, we built a prototype where we shared information using the cloud securely based on policies. Then attribute-based access control, which is sort of the access control for web services and the cloud. And then went into some detail. One of the papers that my colleagues wrote on Hadoop security. So went into some depth on Hadoop security. And then also another group of colleagues worked on MapReduce security. So went into some details. So this was based on some of the papers that they wrote. And so there was fairly in-depth discussions. Then module 4, so once we finished the infrastructures, then were functions. So started with a NIST, a paper by NIST researchers, National Institute of Standards and Technology, and that was an access control model for big data. And that was really very interesting model, that it was really ABAC based model that they developed. So that was based on a paper. And then lecture 18 and 19 were based on 2 papers that I wrote. So 18 was on secure query processing based on Hive for relational data. So how do you process queries? So we processing queries, and then how do you use Hive, which was, as I mentioned, that was a database used by Facebook that they developed, then it made it open source, and now it operates in the cloud. And so how do you do query processing? And then secure query processing based on not relational data, semantic web data. So what was interesting here, we built a semantic web engine, query engine that operated in the cloud because we couldn't find such an engine at the time. Then secure data storage was also a paper I wrote with my colleagues, and that was how do you store the data? So you have a public cloud and a private cloud. So sensitive data goes into the private cloud, and data that is non-sensitive goes into the public cloud. So how do you distribute the data? And then a paper I wrote with my colleagues on how do you maintain privacy and access control in the cloud. So here we talk about big data. It's part of big data because we are using the cloud to store the massive amounts of data. And then I took one example of big data systems, which was Hbase. Now, why did I choose Hbase? For no particular reason, but except that I was more familiar with Hbase. So talked about how Hbase does access control. First of all, what is Hbase about? It's a data model, the tables and column families and so on. And then how does it do access control? And then lecture 23 was a very high level lecture, which I think from a corporate setting, the CEOs and the board and the C-suite, they have to be very particular because they are working with all these massive amounts of data. So what about big data governance, right? So that is important, is becoming an important topic, which also includes security and privacy of big data. So that is big data security and privacy functions. Then module 5 is an application of big data, and we chose social media. Why did I choose social media? Again, I'm quite familiar with social media, how social media systems are designed, how do you query the systems, how do you secure, what about privacy? So one way to explain the concepts in social media to my students, I use semantic web to represent the social media. So that's why I taught semantic web as one of the background technologies back in module 1. So semantic web to represent social media, and then a lecture on security. How do you do access control on social media? And then what about privacy? So we did several experiments on privacy, very interesting actually, to predict whether a person was liberal or conservative. So we took a lot of data, Facebook pages on in DFW, and based on what people posted, we were able to predict, are they liberal or conservative? But we took all the important traits that will be obvious, right? Because if a person says, I voted for the Democratic Party, the chances are he is more liberal, he or she. I voted for the Republican Party, the chances are he or she is more conservative. So, but we removed all those traits. And then we looked at very neutral traits, but still we were able to guess. And we got a lot of coverage for that, because at the same time we were doing our privacy work, MIT, I mean, liberal or conservative, MIT did some work too, where they were trying to figure out whether a person was gay or straight, right? And people get very interested with such topics, right? So so of course, being MIT, they got a lot of coverage. And then we also got coverage. Being liberal conservative is sort of the next more interesting topic, right? So anyway, so that was very interesting. And then lecture 27, social media analytics. So how do you analyze all the social media data? It was very interesting because we've done a lot of analytics with social media. And then what about the privacy implications? So the interesting part with social media analytics is that, is that you can, determine locations of people by analyzing what they are stating. Because often when sort of Google asks me, do you want to divulge your location? I always say no, right? So people don't want to tell where the location is, right? Because for privacy reasons, but based on what you're posting, you can figure out. So, so we want to, but analytics is very important, looking at people's preferences for various food and so on, so you can do marketing, right? But then there are privacy questions. So that's what I focused on. And then what are the various types of attacks to social media, right? So I also wrote a book on several of these topics. I've written books to analyzing and securing social media. That was a book with my colleagues. And I also written a book on secure cloud computing, developing and securing the cloud. And here I wrote a book on securing the semantic web, and then data and application security, integrating databases and cybersecurity. So we also wrote a book on data mining for malware detection. So a number of books that we have written. Okay, so then module 5 is sort of secure data science. We are working on a book right now on the topic. So how do you integrate cybersecurity and data science? So one was, of course, data science for cybersecurity. I'm talking about number 29. That is coming up with machine learning techniques for, I think we had insider threat detection. That was our application. And then we also said, okay, by using cloud, right? Using the cloud, you can speed up things. So we took an algorithm that we had developed, and re-implemented the whole thing. A machine learning algorithm re-implemented the whole algorithm, the entire algorithm in the cloud for malware detection. It was significant improvement with respect to performance. And then we had what happens if the data mining techniques or data science techniques, adversarial machine learning techniques are attacked. So adversarial support vector machines. So went into more details, whereas see, lecture module 2 talked about adversarial techniques at a very high level. We went into more detail, essentially discussed our paper, and then another variation. So data science for cybersecurity. Then we also talked about stream analytics. Okay, so this was more for, I think, intrusion detection maybe, and then stream analytics was for insider threat detection. So we had three very similar. These two were data science for cybersecurity. This was about performance of machine learning, and this was machine learning techniques being attacked. Module 7 was really the next big thing, right? Special topics in big data security and privacy. I really enjoyed this particular module because I learned a lot, especially the last one, quantum computing. So big data and IoT security. So we looked at IoT everywhere, right? What about the access controls for IoT systems? What about data security? What about data privacy? What about network security? Again, IoT systems, right? It's all of this. There are about 160 million devices connected, and I think in 2 or 3 years, it could be billions of devices. And so there's lots and lots of data being collected. So it's very definitely a big data problem. And so security and privacy is important. Blockchain technologies, we know blockchain has got many applications, cryptocurrencies, right? So it provides the security. And so blockchain, so provided an overview of blockchain and then talked about how it's going to support data science and as well as cybersecurity. Of course, when you think about blockchain, you think about Bitcoins, right? Bitcoins is the cryptocurrency. Blockchain is the platform that builds the infrastructure to use these cryptocurrencies. It was really interesting. And I knew blockchain quite a bit anyway, even before that. But this was also very interesting for me to apply to data science and so on. And then lecture 34 was on this big thing called big knowledge. So cybersecurity is meeting big knowledge. So what is big knowledge? There's big data. Is there a big information? I haven't heard that. Big knowledge, again, massive amounts of data, not only data, but you extract the data and make sense out of the data. And then what happens when you bring security? So what I focused was on a theorem called Hbase, H-A-C-E. It's heterogeneous and decentralized and so on, where some of my colleagues, Professor Xingdong Wu and some others wrote a sort of a landmark paper. I think that was published probably around 2014-15, about 4 or 5 years ago. And so I have done some work. I gave a keynote address in the IEEE big knowledge, right? Knowledge graphs. So knowledge graph is an example to represent and reason about big knowledge. Conference on cybersecurity meets big knowledge. So it was a very high level. And then I went into more detail on knowledge graphs. So how can you secure knowledge graphs? More importantly, how can you use knowledge graphs to represent the cyber attacks? So for instance, my colleagues at University of Maryland at Baltimore County, they have done some very interesting work on using knowledge graphs to represent the cyber attacks and reason about the cyber attacks. So I talked about that. And of course, the last topic, that's the big one, right? That's quantum information processing. With respect to cybersecurity and big data, okay, quantum information processing, quantum computing, it is just so huge, right? And it's very real now. Quantum computers can break the code of even 200, and they say 246. We use 256 now, AES 256. And that hasn't been broken because with normal computers, it's probably going to take years and years and years, millions of years. But with quantum computing, they said 248 bits, right, of encryption, it could break it in seconds, right? Milliseconds or seconds. So imagine quantum computing, again, for big data, it is really, really important. And what is interesting about quantum computing is a mixture of physics and computing. Traditionally, we do bits and bytes. It's more mathematical, right? 1 and 0. And so quantum could be not subatomic, right? So photons and neutrons. So it's not just 1, 0, a value. So right now it's 1 or a 0. With quantum computing, it could be 1 and it could be a 0. It can straddle, right? So it is based on the element of processing computation here. The unit of computation is called qubit, right? So that's the unit of computation. So how many qubits do you need for a particular computation? So quantum information processing, without a doubt, it's going to help with massive data, machine learning, AI. But what about cybersecurity? If it's going to break all these codes, right? It's going to be terrible. It's going to be very dangerous because it can break these codes in seconds. And so you've got to develop appropriate solutions where you cannot break the code, right? So there are researchers who have done a lot of work and successful quantum cryptography. That is not quantum computing, but using quantum to develop a crypto system. Right now we use mathematics to develop crypto systems. Instead, can you use physics to develop crypto systems? And you can. So quantum cryptography is very extremely secure, but can quantum cryptography be broken by quantum computing? That's the challenge. And I've read articles where they have said, yes, it can be broken, but again, it's not quite clear. And so that's going to be very interesting, right? And it's going to be very real in 3 years. So the only sort of, I would say, good news and not so good news. Good news from a security point of view, because quantum computing, okay, is 3 years away, but still is very error prone because you've got to do all of this, build these machines and so on, do these computations in in an atmospheric, in an environment which is even as cold as a deep space, right? So that's going to be extremely, extremely cold temperatures. And then any slight perturbation, things could change. I mean, everything could be, all the computations could be wrong. So, so that's a problem. So the results, it's error prone right now. So if they don't fix it, then we won't have decent quantum computing. But then we can continue with our security. But if they fix it, then it's a terrible problem, right? But the thing is, one good thing is that, not everyone has access to all these massive amounts of quantum computing power because it's very expensive, right? Look at the way you've got to compute, going to deep space temperatures. But nations do have especially wealthier nations do have the capability, right? So that's my big worry. That means we really have to, that means that there may not be any security, which means we have to also focus on developing crypto solutions that quantum computing cannot break. And also we need much better detection techniques. So these were the modules I covered. That's it. And so, module 8. Module 8 is, again, I did not go into module 8 because we didn't have time, right? Only, lectures started on August 21st. And then we had the last day of lectures, November 25th, and my students have their exam today. And so they have to turn in their exams today, exam number 2, and the projects were due yesterday. So the point is next semester I've got to, teach the class for my colleagues. So next year, spring, so I'm going to offer this again fall 2021, and then spring 2022, I will perhaps offer a graduate possibly a PhD level course. So my plan was to have, and also we had, another thing is I do have paper readings, but then we had, it was online and I had many students. And so it was asynchronous. So all the students were not expected to be in class. And so as a result, now I couldn't ask the students to present papers, right? So if the class is synchronous, even if it's online or in person, then I can ask students to present, team up and present papers. So sample security papers from big data conferences, because of time constraints, I'm only going to list the papers. So tomorrow I'll select some papers and list it. Such paper reading could perhaps be included. Tomorrow means December 5th. It's early morning today, by the way, December 5th. could perhaps be included in a follow-on course, possibly at the PhD level. So advanced big data security and privacy. What I would like to do is to have PhD students working teams and read the papers, present the papers, and then they do some research. And then they come up with some papers and present their own papers in class. So it would be really great if we can have such a course. So that's my plan for spring 2022. So it's a long time away. Okay, the conclusion to the course, as I said, course covered major topics in big data security and privacy. First, we provided background information. This was followed by core topics, right, in big data security and privacy, including overview, infrastructures, and functions. So module 1 was background, module 2 was sort of an overview, module 3 infrastructure, functions was module 4, and application module 5. This was followed by aspects of integrating cybersecurity and data science, module 6, and then cutting edge topics, right? Such as blockchain and IoT, knowledge graphs, quantum computing, all with respect to security and big data. That was module 7. And in the future, as I said, we plan to have a second part of this course, possibly at the PhD level, to discuss research papers on big data security and privacy, and perhaps the students writing their own research paper. Okay, so I'm going to stop sharing. Right, so I wanted to provide this introduction so that other professors, they will have a chance if they happen to view my presentation. They can also give me feedback on the syllabus. Essentially, I presented the syllabus, the lectures, and what are the other topics I might cover. Maybe they can get some ideas, because one of the things I mentioned in the project is that we will share our lectures with a larger community. So this was the first time, fall 2020 was the first time I taught the big data security and privacy class, and fall 2021 is going to be the second time. So I'm going to make lots of improvements based on the feedback I get from my students and hopefully others. And so once I finish those lectures, then I'm planning to put those lectures on YouTube, right? That's going to be, so hopefully you can expect that a year from now to have all these lectures on YouTube, big data security and privacy. Okay, so I think that's it. And again, this is a very important topic. Although I call it big data security and privacy, it's very much also, I include artificial intelligence and machine learning and data science, also social media and cloud, and then all of the big data technologies like Hadoop, MapReduce, Spark, Storm, and Hbase and Cassandra, and what are the other big data systems, MongoDB, and various other things that I teach. And also, I have a book that I finished about actually 2.5 years ago, almost 3 years, 2018 January, with my colleague. I think that is big data. Oh, it's just, how do I put this? Okay, big data security, no, big data analytics with applications in insider threat detection. So it's from this book by CRC Press. I'm the first author. So it was from this book that I took some of the ideas. Okay, some of the ideas for my for the lectures, especially module number 6 was based on this. Some of the topics that I covered in this book. And now I'm writing another book with 2 of my colleagues, and that's on secure data science. And so hopefully, I don't know that book will be published by the time I have my class. I don't actually use textbooks for my class, in the sense that because I just give it as reference books, not just my book, even other books, but they are not textbooks, because they are, I write 2 types of books, right? One type is for technical managers, because it's, I was at Mitre Corporation for 13 years and then NSF for 3 years before I joined academia. So I found that I had to explain a lot of the concepts to this very high level managers. So I thought, why not write books? So I started writing with data management, and then data mining and multimedia and data and application security, and what else, cloud computing and semantic web. And the second series, which is this book, is we take PhD thesis from students and then we convert them and make them into books. So that's the other thing that we do. And so I've written 5 of those, and the 6th one is secure data science. So that's more for a reference guide, like for a PhD student. So I'm really excited about all these technologies. Sometimes I wish I was younger because there's so much to learn, right? And so much, but it's, again, I tell my students, it's never too late, never too late. And today I had sort of the last sort of conclusion sort of lecture today for my students. And so I sort of gave them some tips and told them, some advice that learning, it has to be a lifelong event. You have to learn, because not only it'll give you, it'll give you a more enlightened and broader view of the world. It's not just that, it can also make you think very deep and critical thinking. But more importantly, what is important about learning is that it keeps your mind really sharp. Because I find I always do study some chapter, like chapter in mathematics, a short chapter, right? Try to do some mathematics problem or something like that. I wouldn't say every day, but probably around five days a week. Because I think yesterday I studied about the power series, right? Then the day before, I think I did some differentiation, right? Workout problems. And then tonight, or maybe tomorrow, tonight is actually 12:46 a.m. December 5th. I might actually study the finance, a model for finance. It's a mathematical model. So various things, it keeps your mind sharp. And that is really important, especially as you get older. And also, I'm hoping to work, being in academia, I can work for until I drop dead, essentially, or until I'm not able to work. Hopefully that won't happen. So I really have to keep my mind sharp, and educating students is just such a joy. So in order to educate students, I've got to continuously learn, because I can't talk about 1975 technologies today. Of course, I can provide that in a summary, but it's really important to keep up with all the developments, right? So the one thing is quantum physics, quantum computing. It's tougher. Although my undergraduate degree was in mathematics and physics, I've kept up with all my mathematics since, all of our papers and so on. We need to still keep up with our math. But physics, unfortunately, I've forgotten quite a bit. So hopefully I can refresh in time. Now I've got so many other things to do with cybersecurity and AI and IoT and data science and big data. So hopefully once I sort of contribute quite a bit in these fields over the quantum computing and quantum cryptography. Right? Whenever we have been in technology, it was in databases in the 1980s, it was the web, latter part of 1990s. And then, of course, now we have the social media, and then deep learning with AI, machine learning. And now, how do you bring all of this together? And why is cybersecurity so critical? Because every time you introduce a new technology, you've got to worry about security, right? And then with quantum computing, the dangerous thing is it can really thwart all types of security controls that we put. So that's another big challenge. And then, of course, privacy, because you can, with all these machine learning and data science technologies, you can put stuff together, and you can infer, you can infer private information about people. So that's another big challenge. So anyway, I will leave you with this. And again, as I said, please, if you happen to see this, please send me comments. And then hopefully a year from now, I'm going to hopefully publish all the lectures for the next